Good afternoon, ladies and gentlemen. My name is James Wenzel, and I'll be talking to you today about the Global Accelerator. We're going to do an introduction on the service. We're going to talk a little bit about how we got there, why it's here, some of the ways that we can configure it, the benefits of it, and then after the session, if you guys have any questions, I'll stick around and you can ask them. Okay? How many of you here have used or heard about the Accelerator? Anybody raise their hands? Okay, cool. So people know what's going on. Okay, so when we're going to start off talking about the Accelerator, first thing we have to do is we have to talk about what does an application deployment look like. Now, I know this is going to be a little bit of rehash of some stuff you already know, but again, this is going to help all of us understand and position why the Accelerator is here and why it's better or different for your workloads versus other technologies that you can use on the AWS space. So, of course, we're going to be concentrating on the networking portion of this. So let's take a closer look. First thing we have is we have our EC2 instances. And then, of course, our VPC, and we have to put our VPC in a region. We're going to build our VPC there. We're going to add in some availability zones, right? We'll add in our subnets. We have our public subnets. And, of course, we hide things back in our private subnets within our AZs. And then after this, we're going to publish it with our instances. We have to have it go somewhere, right? And for our Global Accelerator, it's mostly an internet-facing service. Just like everything else we put on AWS. So we have our public services available, S3, DynamoDB, all of that. And we have to get to it somehow. So we have to do a little bit of routing to get there. First thing we're going to do is we'll bring back our instances. We'll have to check our routing tables. And within our routing tables, we're going to basically set our default route to our local, so all of our machines can talk to one another. Same thing in our private, right? But then we have to get to the internet. And the way to get to our internet is through the internet gateway. I'm going through this a little bit quickly because, again, we know a lot of this stuff. So we add in our routes through the gateway. We get an EIP. We attach our EIP to our instance. Our instance now can talk out to our public services and can also talk out to the internet. The EIP is going to be very important and a very important part of this message. So then we have our private instance, and it's going to go to instance B. Instance B is going to have a NAT service, so it's going to have its own EIP. And pretty much from there, it'll be able to talk out through our internet gateway the same way, and we're going to basically call that our NAT service. We add that to our routing table for instance C, and away we can speak. Basically call it our NAT service. Pretty much everything we know so far. Got our public subnet, we got our private subnets, everything's talking, we're all happy, and then we have our EIPs. Those EIPs are the things that we tell our customers to connect to, or we get whitelisted, for any specific workloads when we work with our customers, or when we go out as a service through our NAT gateway, there's an EIP there. That also has to get whitelisted. So to make our workloads a little bit more robust, we have to do some load balancing. My favorite load balancer, the network load balancer, or NLB. He can go in, accept traffic from the internet. He has his target groups. Those target groups point to our two instances. And then from there, he can actually have a presence in our public subnets to advertise through. And we can basically put those in those two AZs, in the two public subnets. We can add our traffic to it and have our two EIPs, one for each AZ, right? And we can basically check this off and make sure this is all working by just dumping out our NLB, saying, OK, two EIPs. Again, these are the things that your customers are going to be attaching to, looking to get to your workloads, things that they'll have to whitelist. If you have to have a whitelist situation, you give them those EIPs. OK, so the next piece is we want to make sure that this can be global. So what do? We put it on our different regions all throughout Amazon. We have an Amazon backbone. We do have fiber. It does lay across the Atlantic. It does lay across the Pacific. We can control end-to-end from one Amazon point of presence to another what's going on. It's 100 gigabit Ethernet throughout the globe. It's also redundant. We have private capacity. We can basically check what's getting hot, what's not getting hot. We can control those pieces from the backbone. And then pretty much we have about 180 points of presence. We've got 66 availability zones, 21 geographic regions so far, because we always say so far because more are coming. The only caveat that I just want to mention is that with our AWS backbone, the only thing that it doesn't traverse is the People's Republic of China, for obvious reasons that have their laws and mitigations. So why would we have a backbone network? As I was mentioning, security is a big piece. We want to make sure that we know who is going on and who is leaving that network. We can do that by our customers, you guys, knowing who's coming and going on your workloads, and also who we allow into and out of our network from our services. The other thing is reliability. Remember I said that our traffic and our backbone is 100 gigabit Ethernet, but it's also redundant. So we make sure that we have enough capacity and we have enough redundancy within our backbone and our global network so that if there is an issue, you don't feel it. You don't feel it, and your customers don't feel it. And of course, availability, just as I mentioned before, we want to make sure that our network is always available. We always have those redundant paths. We have more capacity than is needed on our backbone. And we always want to make sure that we can stay ahead of you so that you don't have to ever come back to us and say, your network is slow, our customers are suffering. We want to make sure we reduce that. And then, of course, get us closer to your customers. In our backbone, remember I mentioned our points of presence, those small outposts on our edge network. We can place them as close to your customers as possible and get them onto the Amazon backbone, reducing the latency, getting them to your workloads as fast as possible. It's all about making sure that your customers feel the best experience that you can offer them, and that we are not impeding that for you. And of course, all inter-region traffic, if you have something in one region versus another region, all stays on the Amazon backbone. So if you have something going in US East 1, and it's going to go over to Frankfurt, and it has traffic in between it, it doesn't go to the public internet, stays in our backbone. So we have a single region deployment. Remember our workload that we just talked about, our application workload. We'll say we'll put it in US East 1. We have our users that are going to be appearing in Seattle, let's say, and they want to talk. They go ahead and start talking to that software that you produced. And let's say that the software that you produce is very popular. So people around the globe also want to talk to it. So they go ahead, and they're all talking to that workload. Right now, in this scenario, those customers are going to be going across the public internet from all around the globe to get to your workload sitting in East 1. Now, there's a lot of things that can happen between coming from Asia, coming from APAC, coming from Europe, getting to the workload. There's a lot of places where latency can be introduced, hotspots, all that stuff. What do we do about that? We'll deploy in multiple regions. We'll try to bring our workloads closer to our customers, right? So in this scenario, they can go to the IP addresses that you assign to them. They all start talking. Everybody is happy, right? Well, we have a user in Seattle. He's going to talk to our workloads. Each of our workloads, remember the yellow EIPs from when we first did our application deployment? They're going to make a request, Route 53 or some DNS. DNS is going to make a response and say, hey, to get to your workload, to get to your application, go to this particular IP address, and it's going to be cached on their local workstation. And then they go ahead and they talk. So what happens when we have a failure? Right? So we'll say, well, we've got regional deployments. We can easily do a failover to another section around the globe. So they're going to make a request. We're going to send them to the next closest one. Right? They come back. But the problem is we don't control their cache. So if they don't have good cache management, you might have to wait for timeouts. It might have some issues. So they may still go to that old application or that old location where the application is down. They'll see failures. They might see a 404 page or something that we don't want our customers to see. You want them to believe that everything is up and everything is seamless. One of the ways that this can also affect you is this can control when your maintenance times are. If we know how the cache is and the cache timeouts, and I've seen this with a lot of customers, they have to actually orchestrate when they can do work to their workloads based on their customer's cache timeout, which is usually in the middle of something, right? Middle of the night, middle of your kid's birthday party or whatever, something unpleasant. So here's some of the challenges we talked about today. Cache is a challenge, right? Routing over the public internet is a challenge. You can never really predict how your experience is going to be when you go hop over other people's local loops, through other people's NAPs. I mean, we've all experienced this at one point or another where we're like, it's the internet, what are you going to do, right? But for our customers trying to use our products, that's not a really good experience. It's not a really good explanation. Sorry, customer, it's the internet, what do you want me to do about it? So that's what we're doing. And of course, some complex things through the internet as well, depending on where you're going, what you're doing, and what parts of the internet your product relies on. You might have to do some funky routing. You might have to do some natting or something crazy, and you have to maintain that. And every time you do a upgrade or every time you do a new release, that has to be kept in mind, right? How many times has anyone ever gone and had to mess with something in their routing just to find out that it's messed up something else because of that one special thing, because of that one special use case on the edge? So we have Global Accelerator. Now we'll start talking about more of the meat of what's going on. So you got your client, we introduce our Global Accelerator, and it will enhance the availability and performance. Because remember, the Amazon backbone, we control end-to-end. So we know the latencies end-to-end. We've been monitoring and searching and seeing where the hotspots could possibly be, and then we can increase the capacitance. Global Accelerator gets you on that path. So let's talk about a little bit how it works. We have our EIP addresses, right? But we're going to obfuscate those EIP addresses. Your customer in Seattle now, he makes a request. He's going to basically do the same thing. Route 53 makes a request to go to your example.com, to your workloads. And then everywhere, the response from Route 53 is going to be one IP address, the same one. It comes back, IP address is there, caches that single IP address now. Everybody's happy so far. We start talking. Great. But what about that whole Andy Jassy, everything fails all the time thing? We can be sure that something will fail. Let's go back 1 second. So one of the other things I wanted to point out, too, are secondary IP addresses. Everything with it, everything fails all the time. Even when we're doing something with Global Accelerator and we have 2 different IP addresses now to also handle your workload, just in case we have a failure inside, we're not going to leave you with one IP address holding the bag. We're going to give you another one. The other thing we're going to do is we're going to take advantage of the edge. All those points of presence that I talked about that we have, this Global Accelerator actually lives there. So these Anycast IP addresses are going to be sitting on the edge, and they're going to be all over the globe in different locations. You'll notice that our user in Seattle is closer to an edge than he is to US East 1. So when he wants to talk to your application, Global Accelerator figures out, OK, this is the IP address from the users in Seattle. This is where he's coming from. I know he's in Seattle. We have a point of presence there. That's directly connected to our backbone. Let's have him go through there. And then he starts talking to our applications. Same thing if we have users in other locations, right? We're going to basically send them over to the closest point of presence into the Amazon backbone to get to your application, reducing latency, reducing anything that can happen on the internet. So here we are. We have a failure yet again, but now it's not in the same place because our friends in US East 1 learned what not to do, and our friends over in the other side of the world now see a seamless change. They actually don't even perceive it. They just immediately start going to the closest location of where your workload is. Their IP address is exactly the same, right? That Anycast IP address, the one that we showed before within the cache that would expire, we don't have to wait for that anymore. Their clients are just basically going to the same IP address. All the routing, all of the thought processing, all of this will happen in seconds, getting them over to your workload that's actually sitting now in Europe and servicing your customers. So taking a closer look, we'll build our applications up a little again. We're going to talk about how we do this with Route 53. Our users go ahead and they start talking, right? We've got our 2 IP addresses for our 2 different regions. Out they go. Everything is great, except for the whole caching problem and all that fun stuff. What do we do for our Global Accelerator? This is that POP, that point of presence that we talk about on the edge. It sits as a layer on top. Basically, we have our 2 IP addresses, those Anycast IP addresses that they will have in their cache, that they'll have in their browser, that you have in DNS, and they will go ahead, users will talk to them and go to the EIP addresses of your actual workload. This is very helpful, again, for if you have to do maintenance, anytime you have to do a changeover, upgrades, all of that stuff can be obfuscated where you can actually also move things around behind the scenes instead of also having to wait for a failure. So some of the key features of the accelerator. First key feature is you get a redundant pair, as I mentioned, of Anycast IP addresses. We'll talk a little bit about how this looks under the hood with different zoning and where those IP addresses come to play. But you could put both of those IP addresses into DNS. You can have those things whitelisted, all sorts of fun stuff. The second piece is the intelligent traffic distribution. We have a bunch of things that we do behind the scenes in Global Accelerator, 5-tuple hashes, 2-tuple hashes, different rules that you could also set to help direct the traffic. Also, with our backbone and the metrics that we know of our backbone, hotspots, rerouting, our Global Accelerator knows about this. So it'll help shape the traffic from your customers to your workloads as intelligently and as quickly as possible. And then, of course, we have our targets. And targets for the Global Accelerator could either be an EC2 instance or our load balancers. And there's benefits for both. Load balancers, there's a lot of inherent capabilities that we'll talk about. And EC2 instances could be pretty much whatever you need. And then, of course, lastly, it's pretty easy to set up. It's just like setting up an ELB. It doesn't take a lot, not a lot of rocket science to set this thing up. If you're familiar, some of you have already mentioned you're familiar with Global Accelerator. If you're familiar with load balancers, this isn't something that's too far off the mark. And then all of our traffic, every bit, again, and I'm going to hammer it over and over again, goes over our backbone. And we want you to go over our backbone because we want you to have the best experience that you can have, especially your customers, except for, of course, China. So before Global Accelerator, you have your workload. It's on the internet. And it may have to go through a local ISP and go through many different hops. And when you go in one direction for your traffic, it may not be the same coming back. The internet moves and changes pretty constant. And this pretty much doesn't give a consistent experience because you can have latencies introduced in different places. You can have problems in different places. Again, that one thing, what are you going to do? It's the internet. So what are we going to do? We're going to do this. Global Accelerator brings it closer to your customers, getting them on the pop as fast as possible, reducing how much public internet they have to traverse, and then connects them up to your workload. Then the only thing you have to worry about for latency is between them and the local ISP. And if you have any latencies with the AWS backbone, you can always call us up and complain. At least you can say, hey, I have someone to complain to, right? So how does it choose an endpoint? This is pretty cool. Geo-proximity. It's very similar to the technology we use in Route 53, where we know where the IP address is coming from, and we can basically point them to the closest local hop. There's a setting that you can choose called client affinity. And client affinity basically says if I have something or a workload where when I start talking to one of my endpoints or parts of my workload and I need them to continue, like video processing on multiple ports, something like that, you can set that. So that also takes an effect. Well, now the piece is also your configured policies for weights and measures, how much traffic you want to go to one place versus another, how much region traffic you want to accept in one region versus another. These are all dials and things that you can choose. And then, of course, application health. If something fails, the Global Accelerator will remove it out of play. So if a region goes down, an endpoint goes down, it will simply no longer send traffic there. Of course, you'll get your notifications, but all of this, again, seamless to the customer. Your cached IP addresses are all the same IP address, all that fun stuff. So let's take a little look at how this works. So it picks the optimal region. It does a 5-tuple hash check. Protocol, source, destination, target, destination, and source, and then start sending traffic over within the region to where you want it to go. If you set your client affinity, you would typically set source client affinity. You can have your conversation go to the same workload, as I mentioned before. The client starts talking, doing some video editing, or playing a video game or something, has to keep on communicating with the same endpoint. There you go. You can set it up, and you can tell it, if we have an affinity set up for this workload, keep going to the same place. And of course, when you're doing source client affinity, we use 2-tuple, which is basically your source and destination. Those are the two main pieces that you need to know about. Now we're starting to talk a little bit more about those things that you can configure, your regional traffic dials. Regional traffic dials allows you to send a lot of traffic to one region and to another. You can split the traffic between regions. And this is basically, the key point here is, this is how much traffic your region is willing to accept. So let's say, for instance, in our top region here, we're going to do some maintenance. We turn our traffic dial down to 0. And as you can see, all of our traffic now will basically avoid that region. We might be doing an upgrade. We can be doing a rollback, something that we're doing to that region that you control, and it's outside of a failure or something like that. And then even further going down into the rabbit hole, we can actually configure our endpoint weights. So not only can we configure how much traffic goes into a particular region, we can also say within the endpoints that we set up that are attached to those ELBs, that are attached to our EC2 instances, how much traffic do we want to go to each one? We might be introducing something like red-green. We may be ramping up something, ramping it down. This is a good way to slowly bleed that stuff off. And health checks. Another thing, too, is we have our traffic. Everything's going fine. Again, I'll go back to everything fails all the time. We have a failure on our ELB. The global accelerator, again, will just simply route traffic to everything but that one failed piece. And again, you don't have to worry about changing IP addresses. There's nothing that you have to do on your client's end. They see nothing different. Of course, you'll have alerts, and you'll go ahead and do something to this. But for your customers, they don't see this. This is hidden behind the scenes. And that's one of the more powerful things about the global accelerator. So how do we configure it? So there's three main pieces. The first piece, you'll get a set of IP addresses after, right? These are the Anycast IP addresses, the primary and secondary, or as we call it, Zone A and Zone B. These are the redundant pair that you'll hand out. The next thing you do is you have your listeners. We have two types of listeners. We have TCP and we have UDP. And within that, you configure the different ports. Here, we've just got 80443, and we've got DNS listening there. And then you have your endpoint groups. These are the things that the traffic will go to. So the customers attach to those IP addresses. They go through the ports that you've configured on your listeners, and then it goes to the endpoints, and they reach your actual service. So how do we configure this? How do we set this up? I promised you it was easy. Let's see how I worked out. So what I would do is I'd go into the console. You can do a search, Global Accelerator. You go ahead, and you would click Create Accelerator. That will take you to the next screen, which you will name your accelerator. And then from there, we'll go ahead and we'll add our listeners. One thing that's important to note about our listeners is that if you choose client affinity, choose source IP. And that will basically route the traffic, as I showed you before, get the traffic going to where it needs to be for any type of affinity, video ingestion, all of that fun stuff. And then, of course, for TCP listeners, you get health checks. For UDP, we don't have that quite yet, but what people tend to do, or customers are tending to do, is they'll make something like a page that says, okay, I'm an up page or a all is well page, and they'll create a TCP listener to it, and it will go ahead and figure it out if it's up or down. Now we have our listeners side by side. You can create your endpoint group in the regions that you need. You can keep adding regions, and then from there, you can also do your traffic dial. This is how much traffic I want to go from one region to the other. This is where you would set that up. And then we can go ahead and configure our TCP health check if we have any IP, or if you needed to set up a TCP health check for a UDP-based workload. And that looks pretty similar to most of the health checks that you set up on any ELBs. You can, go ahead.
Sorry, if my workloads are in multiple AZs within a region, how would you configure that?
If your workload is in multiple AZs, basically that's based on the endpoints. So the endpoints being the ELBs, you just point it to whatever ELB you want. The global accelerator really doesn't care which availability zone it's in.
Split I cannot do within AZs.
What's that?
The split of traffic, I can control at the ELB level.
Yeah, so that would be your endpoint weights, right? So here we're configuring our health checks. One thing to note, too, on your endpoints, if you're using ELBs, NLB or ALB, if they have a health check configured, you don't have to recreate that with the global accelerator. It will actually suck that in and use that health check. Creating a TCP health check is for TCP-based workloads on an EC2 instance. So health checks are only for elastic IPs. The health checks are inherited, as I mentioned. Also, you can have TCP, HTTP, or HTTPS. So again, we're encouraging you to make that everything is working fine page that your accelerator goes to and checks, and then it matches up. Everyone is happy. And then remember, UDP, if you're going to do a UDP workload at this time, create a TCP health check for that same workload, and then everything will go fine. So side by side, we have all of our region endpoints will show in the dropdown. So when you go to choose your endpoint, and this is very soon coming up on your question about the weights, if you choose what type of endpoint you want, it will automatically show you what is available within your region, right? Because remember, this is a regional construct. You would configure that, and then you can portion your traffic with your weights So within the endpoint weights, this is that section where you saw on the previous slide. I want this much traffic to go here, that much traffic to go there. And then when you click done, you'll notice that your accelerator is up. You have 2 sets of IP addresses, as we mentioned. Everything is going happy and fine. And away we go. So the next piece that's important, high availability. So the 2 network zone thing, we're going to dig into that a little bit, show you how that works kind of behind the scenes for the global accelerator. We also have the contiguous health checks. The health checks, just like on your ELBs, constantly checking, pulling in the information from the ELBs, running that health check that you set up for TCP against your workload to make sure everything is working fine. Then we have DDoS protection. How many of you are familiar with Shield? Okay, so we have a service called AWS Shield. This is a service that's working with our security team. We look for bad actors. We look for known bad IP addresses, any type of SYN attack or those type of things. We actually monitor for that. We'll notify you if that happens, and in some cases, if it's extreme, we'll block it. That's part of this service as well. Now that you're taking your IP address and you're taking your workloads global, the more you go around the globe, the bigger of a target you are. We want to make sure you're protected. And of course, you have your AWS global network, the backbone that we were talking about that you're taking advantage of. High availability, redundancy, 100 gigabit E, you're good to go. So digging in a little bit about the network zones on A and B. You'll see here in this diagram that we have 2 sides. All of our packet engines are duplicated within every point of presence. So of all the point of presence that we have, double the presence in each point of presence, and that's how much redundancy that we have. So if one side, for heaven forbid, goes down, the other side can pick up and take over. So you're not out of the water if your global accelerator has an issue. I'm going to knock on wood real quick. OK. So how does the DDoS protection work? We have our good client, and we have our bad actor. I'm sorry, our bad actor has a white hat that was pointed out to me at one point, but if I give him a black hat, he'll disappear. So they start talking. And we have good and bad traffic, right? It hits our global accelerator, and because of Shield and because of the Shield service, we have the ability to filter out that bad traffic or notify you that this traffic is happening, and then you can decide for yourselves if this is truly good or bad traffic. But it helps keep things flowing along. It keeps a lot of the unwanted bandwidth off of your network. It keeps getting failures down from things like attacking. So let's talk about how much this guy costs. We have a fixed fee, 0.025 cents for every hour or partial hour that the global accelerator is running at. And then we have our data transfer fees. And this is all publicly referenceable. You can get this on any of our web pages if you look up global accelerator pricing. It bases on region. So why would I use it? So we have a couple of them. The one big one is whitelisting. A lot of times I'll get from a lot of customers, I need a contiguous list of EIPs, 24 IPs to be able to cover my expansion, and I want to be able to give a CIDR block to my customers so I don't have to keep going back and telling them, add this IP address, add that IP address. It's just a bad experience for your customers. So with this, again, with the Anycast IP addresses, all you have to give them now is 2 for that particular workload around the globe. That's it. The only time you have to give them new IP addresses is when you come up with a new global accelerator and have new workloads. UDP traffic is supported in this. A lot of things that you can think of, like voice, would be considered part of it, some part of audio for data. This is also supported, again, by our accelerator. And then, of course, live video ingestion, where sometimes it requires multiple ports. That's where you turn on your affinity. You can have it all go to the same machine. But again, all of those people on the cell phones that want to upload their cute kitty pictures, they only have to connect to one IP address that you have pre-configured in the client. You don't have to send out any reconfiguration notices. If you make any changes, it doesn't have to come to a new download of a client just to change the IP address. We also have our multi-region applications. Think of some things like financial services, point-of-presence machines, like checkout stands. They can all be configured same way as the phone for the video, pre-configured with one IP address that isn't going to change. And they can get as close as possible if one of those pops onto the AWS backbone. You don't have to hear that dreaded, oh my goodness, I'm sorry, we only accept cache today because our computer is down, for the point of presence thing. And then, of course, API acceleration, any type of the ad world, ad ticks. You have something in your application that sends out a bunch of API calls to your applications in other parts of the globe. This, again, stays all on the Amazon backbone. So very latency sensitive workloads, very, very strong value prop for that. Again, because of the fact that we can control that backbone, you don't have to go over the general internet and rely on what's going on there. So who's using this today? Is somebody actually taking advantage? We do. Our friends at FlowPlayer, they will allow their customers to send video up through their mobile devices or their laptops. And again, the whole multiple ports thing goes to the global accelerator, closest pop, and it's constantly going through an NLB, and it's being churned by their servers and being placed up on the web. IP whitelisting for our friends at PAR. I was just talking before about our point of sale services. These guys, they don't have to reconfigure or go back to all of their clients if they upgrade or do something new to their workload. They just preset it. IP addresses stay the same. Same thing, they have the advantage of the different points of presence, stay on the Amazon backbone, all as well. And then lastly, voice over IP. And this is a pretty interesting one because on the other two, you'll notice that it's always the users connecting to AWS, connecting to your workloads. Well, for Crazy Call, they have people from all around the globe connecting to the closest point of presence on their mobile device. And that closest point of presence brings them to their workloads and allows them to have their voice communication actually happen over our backbone. And again, because of the reduction of latency, we don't have to worry too much about jitter, all that fun craziness. They can have a good customer experience. So what does this mean for you? The Global Accelerator comes with all of its robust architecture. You get your increased network stability and your speed. You get your NAcast IP addresses that you can whitelist, right? So that you don't have to keep changing those about. You get our global backbone, right? Low latency backbone. And you get our health checks and traffic control, weights, and dials. So you have full control over everything that goes across your global accelerator, right down to the endpoint, right from the region, all the way up. And that's it. Does Global Accelerator support bring your own IP? Not at this time, but it is in the works. Is there any other questions? You were first.
Talk about affinity rules. Would you always need affinity for TCP?
The question is would you always need affinity for TCP IP? It depends on the or TCP, thank you. It depends on the nature of your workload. Some workloads are stateless, where it doesn't really matter. It can go to any of the servers.
Two packets from the same TCP session, they have to go to the same place.
Oh, sure, sure. I mean, it will keep the same flow and stream. But what we're talking about with affinity is if you're using two different ports, right? So if you're sending something over TCP as well as sending something over UDP to have interaction, you can make sure that those always land on the same server.
So it does maintain affinity for a flow.
Yeah, for flows, it will absolutely maintain that affinity.
How do you do that, especially part of it routing over the internet to reach the first pop?
Yeah, so
That's always the challenge with any TCP session. You can't guarantee that all the packets will go to the same destination.
correct. We actually, within the NAcast IP address, seeing how it's going to the same IP address, once it gets onto our hop and we can encapsulate that traffic, that's how we can actually maintain and control that flow.
To get to your network.
Oh, sure. Will your network on-prem or your network in the cloud?
If part of this, so if the end user traffic has to traverse the internet to reach the Amazon top,
Mm-hmm.
even at that layer, it has to always go to the same place, right?
Right. Yeah, that's where it's actually flowing it to the local point of presence. That's where the kind of the magic happens. So when it finds out what IP address you're coming from, it's always going to keep it going to that same point of presence. It's not going to send some traffic to one and then other traffic to the other. And then once it gets into the point of presence, that's where the packets get encapsulated, and then they get sent onto your workflow. It would, but generally it won't go to two different points of presence unless an action has happened. Either you've told it by your weights and dials that I want to make a change, or there's a failure. Yeah.
So for the client affinity, what are the other options other than source IP?
For affinity, right now source IP is the main option that you would pick.
But like, if the data is sharded between the regions, let's say I want European data to be in Europe,
Mhm.
GDPR or other regulations.
Right.
If I select source, can I select something other than source, like a geolocation or something?
A geolocation actually will happen automatically right now with it. If you need to be absolutely sure, if you need to absolutely make sure that GDPR, that your traffic is only staying within a specific region, then you would look at something like the geo rules for Route 53, coupled with the global load balancer or the global accelerator. Yes?
Yeah, you mentioned in the use cases about acceleration and performance, but this seems like a really great serverless way to solve DNS Apex issues where you use static IP.
Yeah.
Like, is that something you see this being used for, or is it kind of priced out of that?
No, I mean, we do see, it depends on, it really comes down to the use case, right? But you're absolutely right. I have definitely seen customers use it for Apex.
Okay, question. You used ELBs in your examples, but they didn't seem to be listed as an actual backend option.
Oh, so when you're configuring your endpoint groups, your two options are EC2 instances or ELBs. So they will go into your endpoint group. Does that make sense?
Okay, I only saw NLBs and ALBs at the end.
Yeah, I mean, it's general ELB. I just chose NLB for some of the particular things.
Does the ELBs have to be public or can be private?
The ELBs have to be public. You have to have that EIP for it to talk to.
What if I need like PaaS services?
What's this?
PaaS, if I'm not using ELB or EC2, if I'm using like DynamoDB or something.
Right now, it doesn't connect to those. You have to have that IP address, that EIP address to communicate with. Yes, sir.
This is not available in all regions yet, right? Like in Europe, I don't think it's available yet.
So the Anycast, basically with Anycast, you can make it look that way, and you can set it up, and as they light up, it will automatically start routing through. So in the regions that it isn't yet, you can kind of start the work now. Anybody else? Okay, thank you very much for your time.